Okay, so today is 110, mathematical modeling and variation. So our warm-up, find the particular equation for the function below such that f of 2 is equal to 4. Go ahead and press pause, give it a try, and then come on back when you're ready. All right, so one way that we could go ahead and do this is we could say, well, if f of 2 is equal to 4, then that means that x must be 2, right? So if x must be 2, then what we can say is that anywhere that we see x, we can replace that with 2. So 4 must be equal to 2 squared minus 2 times 2 plus c. So 4 must be equal to 4 minus 4 plus c, which means that 4 must equal c. So my particular equation would be f of x is equal to x squared minus 2x plus 4. Okay, so today we're going to talk about variation, and there is 2 different types of variation that we will be looking at to start with anyways, is direct variation and inverse variation. So I want us to think about this idea of this pond, okay? We have frogs, and then we also have some sort of a bug, okay, that the frogs are going to eat, okay? So if we increase the input, so what if we increase the amount of flies? Then the frogs might increase as well, or vice versa. If we were to decrease the number of flies, then the number of frogs might decrease as well, okay? So as I increase the input, the output also increases. This is an example of direct variation. Inverse variation, on the other hand, is a little bit different. So for inverse variation, what we would be looking at is what happens as I increase the input and the output decreases. So what if I increase the number of frogs? Well, then the number of flies is going to decrease, all right? And so we have to kind of think about that as an inverse variation. So as one of the things goes up, then the other one would go down. So the input increases, the output decreases. Mathematically speaking, we can look at this as different formulas. So direct variation will always take the form of this: y equals k times x. Notice as x increases, y is going to increase, or as x decreases, y would decrease. Inverse variation instead would be y equals k divided by x. K is called the constant of variation. It represents how much one varies with the other. And so oftentimes for most scenarios, this is going to be a situation where you will have the K will be constant for the entirety of the scenario. So whether it's a table of values, a graph, or an actual real world type of a problem, the K value will be the same for all of that. Okay, so here's an example of what we might see. We have y varies inversely with the square of x. If y equals 12 when x equals 2, find an equation to represent the relationship. So the first thing that we want to do is we want to find an equation. So think about inverse versus direct. Which one is this? It's pretty clear here. It tells us that it varies inversely. Sometimes you'll also see the language is inversely proportional. That means the same thing. Okay, so I'm going to use this idea that y is equal to k divided by, now normally we would just have x. I apologize, my husband is sneezing. He says sorry. So y equals k divided by, normally we would have x. But this time it says that it varies inversely with the square of x. So we'd have to have x squared here instead. Okay, so that's my equation. Then the next step is that we are going to plug in values to solve for k. All right, so the given values that they tell us is that, well, for this situation, when y is 12, x is going to be 2. So notice I just plugged in 12 for y and 2 for x. And now we basically just need to solve for k. So I would have, well, 12 is equal to k divided by 4, and I could multiply both sides by 4. So k would equal 48. Okay. Now, step 3 is to write an equation using the k value. All right, so we don't want to just solve for k. That's not our goal. Our goal is to find an equation to represent the relationship. So we would end up writing an equation y equals k would be 48 divided by x squared. This way I could plug in any x values and solve for y, or any y values and solve for x. This would be my final answer that I want to get. Okay, next example. It is possible to have two variations happening at once. So in this case, we are going to say A varies directly with B and inversely with C. So A varies, for my equation, A varies, so A equals, directly with B. Now direct means that we had K times B. Okay, and inversely with C, well that just means that the C is in the denominator. Okay, so this would be our basic function, okay? This asks us to find the constant of variation, so we're trying to figure out what k is. If a equals 12 when b equals 2 and c equals -3. So they give us a, b, and c. Let's plug those in. So I'd have 12 is equal to k times 2, or 2k, divided by -3. And all we have to do is solve. So I can multiply both sides by -3. I get -36 is equal to 2k. K is equal to -18. And notice here, it's not asking us to write an equation for it. We could have, but ultimately they just asked us to find the constant of variation, so we're just finding K. Okay, another type of variation, joint variation. Joint variations just basically mean that multiple variables vary directly. So notice if I have z, x, and y, this would be like z varies jointly as x and y. Or you could also say z varies directly as x and y. So either way, okay? This is an example of that other language that I was talking about as far as being proportional. Instead of varies, sometimes it uses the words proportional, okay? So the time a cake takes to bake is jointly proportional to the number of eggs and to the temperature of the oven. If a cake with 2 eggs takes 20 minutes to bake at 350 degrees, write a model for baking time. So our goal is to come up with a model for baking time. So it looks like we've got 3 variables happening here. We have the total time, we have the number of eggs, I'm going to use E, and then the temperature, I'm going to use a lowercase t. Okay, those are kind of our 3 variables. So the time it takes to bake a cake is jointly proportional, so that means K times the number of eggs and the temperature. All right, you might have chosen to use Z, X, and Y, and that's fine. You can do that. So now our goal is to figure out what K is so that we can write this model for baking time. So if I have T, it takes, the total time would be 20 minutes is equal to K times E, that's the number of eggs, so that's 2, times T, which would be 350, because that's the temperature. This would be 20 is equal to 700 times K. And if I divide both sides by 700, I end up with K is equal to 20 over 700, which would be equal to what? 2 over 70 or 1 over 35. So my final answer here is going to be that T is equal to 1 over 35 times E times T. Okay, and you might have used something different. I'm looking at my notes from last year and I used like B for the total baking time. Use whatever variables work for you. Okay, I want you to go ahead and using this variation language, try to write a sentence to describe the formula. Go ahead and take a second, press pause, see what you come up with. I'll give you mine, but yours might be slightly different, which is fine. Okay, so here's what I came up with. I came up with F varies jointly as M1 and M2 and inversely as the square or with the square of T. Okay, yours might have varied differently as well. That would have been fine. If you would have said F varies jointly, or sorry, F varies directly as M1 and M2, that's fine. And inversely with T squared instead of the square of T, that would be fine as well, okay? But you should be able to write out words to describe this, and then also having the words be able to translate that into an equation form. Okay, last question of our videos. I apologize if I'm sounding a little run down. My voice is starting to get tired from making all these videos. So the distance S that an object falls when dropped from some point above the ground varies directly as the square of the time t it falls. If the object falls 19.6 meters in 2 seconds, how far will it fall in 10 seconds? Whew, that's a lot. Okay, let's go back up to this first part here, because this is what tells us about our equation. So it says the distance S that an object falls when dropped some point above the ground varies directly. So S varies directly, so that'd be K times the square of the time it falls, T squared. Okay, now they give us some information. If the object falls a 19.6 meters, so that would be our distance, in 2 seconds, that would be our time. How far will it fall in 10 seconds? So this one's going to actually add one extra step from those first ones that we were doing. I know a value for the distance and the time, so I could solve for K. Let's start there. So if I have 19.6 is equal to K times 2 squared, this would be 19.6 equals K times 4, right? And if I divide both sides by 4, K is equal to, just trust me on this one, 4.9. Okay. All right, so if K is equal to 4.9, then that means that my equation looks like this. S is equal to 4.9 times T squared. Now, I want to add kind of really quickly a step 4 from those first steps that I gave you guys on that first slide with an example question. Step 4 is to use the new equation to solve the problem. Okay, because I'm not done here yet. I didn't just ask you to write an equation. I asked you how far will it fall in 10 seconds. So what I want to know is what is S if T is 10? So this would be S is equal to 4.9 times 100, or S would be equal to 490. Oops, that should be the 9. Okay, 490. Now, let's give this a little bit of context because 490 means nothing outside of what the context is here. So I would say an object falls 490 meters in 10 seconds. That would be a complete answer here. It doesn't need to be anything too crazy as far as your context sentence. You just need to do something with it. Okay? So that is all for 1.10. And that's all for the videos. You're going to use the remainder of your class time just like you did yesterday to work on the homework assignment. This homework assignment will be due on Monday along with your projects. So your projects are also due on Monday. So just kind of keep that in mind as you're working through over the weekend. If you need to use this time on your project as well, that would be fine to do. We will have a review day on Monday, and then we will have our test on Tuesday. So I will be back on Monday to run through the review day with you and answer any questions that you guys have. Have a great night.